For most of human history, cooking has been all about tradition, taste, maybe a little bit of magic. But we're entering a whole new era. We're moving way beyond just following recipes and into a world where our food is being engineered with, well, incredible molecular precision. We're about to pull back the curtain and see how science is literally rewriting the menu.
And this quote, it just nails it. The kitchen is evolving into a hub of precision engineering. I mean, that's a pretty bold idea, isn't it? It suggests that our kitchens are becoming less about guesswork and more like a science lab. So in this explainer, we're going to unpack what that actually means. So here's our plan. First, we're going to show you the hidden science that's already happening in your own kitchen. Then, we'll look at how scientists are cooking up brand new food experiences from scratch. We'll get into the clean chemistry revolution, zoom out to see the entire smart food system. And finally, we'll take a little glimpse into our wild molecular future.
All right, part one, your kitchen is a laboratory. Now, that might sound a little bit out there, but seriously, every single time you cook, you're running a whole series of chemical experiments. You just probably don't call them that.
Just picture these two people, right? You've got the classic chef who knows from years of experience that if you sear a steak, it gets that amazing flavor. And then you have the food scientist who can tell you exactly why it gets delicious, right down to the molecules. But the big question is, are they really all that different? As you'll see, that line is getting blurrier by the minute.
And this is the proof. This is all the science you're doing without even thinking about it. When you cook an egg and it turns from clear to white, that's its proteins unfolding and tangling up. It's called denaturation. Or that beautiful brown crust on a seared steak, that's the Maillard reaction, a chemical cascade that creates hundreds of incredible new flavors. See? These aren't just cooking terms. They're bona fide chemical experiments. And that leads us perfectly into our second section, engineering new food experiences. Because here's where we make the jump from doing science by accident to using it on purpose to create foods that were, frankly, impossible before. We are literally moving from recipes to algorithms. The field that's making all this possible is called molecular gastronomy. Really, it's all about obsessively understanding the why behind everything that happens in the kitchen. Why does a cake rise? Why does ice cream sometimes get icy? If you can answer those questions, you can control the outcome with unbelievable precision. So let's look at a classic example, spherification. It sounds complicated, but here's the deal. You take a liquid, say mango juice, and mix it with sodium alginate, which comes from seaweed. Then you drop little blobs of it into a bath of calcium. The calcium ions instantly act like tiny little magnets, linking up all the alginate chains. The source material calls it an egg box structure, which is a perfect way to picture it. It creates this super delicate, edible skin around a liquid center. The result? These amazing little spheres that just burst in your mouth.
But it's not all just chemical tricks. One of the biggest game changers in modern food science is precision temperature control. Think about sous vide cooking. By cooking something in a perfectly controlled water bath, you can get a steak or a piece of chicken cooked perfectly edge to edge every single time without losing any moisture. It's a level of control chefs used to only dream about. And then there's the other end of the spectrum, negative 196 degrees Celsius. That, my friends, is the temperature of liquid nitrogen. When you use it to freeze something, it happens so fast that those big, crunchy ice crystals don't have time to form. It's the secret to getting ridiculously smooth ice cream, and it also locks in delicate aromas that would otherwise be destroyed. Okay, on to section 3, the clean chemistry revolution. This is where we stop just manipulating the food we have and start actually designing our ingredients from the molecule up. And believe it or not, the push for this is coming from us. Yeah, look at that number. A whopping 75% of us are flipping over the package and rethinking a purchase based on the ingredient list. That consumer pressure is forcing the food industry to find natural, clean label alternatives to synthetic additives with those confusing E numbers, like titanium dioxide, which was often used just to make things look whiter. So how do they do it? How do you make something like a creamy salad dressing without a bunch of weird additives? Well, you go back to nature. You use a natural emulsifier, like lecithin. The easiest way to think about it is like a molecular matchmaker. One end of the molecule absolutely loves water, and the other end loves oil. So it literally grabs onto both and holds them together in a perfect, stable mix. It's the original kitchen chemistry, and it's been hiding in egg yolks all along. Now hold on, because this is where things get really wild. It's called precision fermentation. Basically, scientists can use microorganisms, like plain old yeast, as tiny little factories. They can give the yeast the genetic instructions for making, for example, the main protein in milk. The yeast then just brews it. The final product is molecularly identical to the protein from a cow, but it's made completely animal-free. It's incredible. So all this amazing science isn't just staying in fancy restaurants and labs, it's scaling up. And that brings us to Section 4, building the smart food system. These molecular innovations are starting to change the entire journey of our food, from the farm all the way to our forks, making it safer, more efficient, and more sustainable. So you have to ask, how big of a deal is this really? Are we talking about small, minor improvements, or is this a total revolution in how we produce and process our food? Well, let's take a look.
This chart really puts it into perspective. Look at safety testing. Instead of waiting 48 hours for a culture to grow in a dish, we can get real-time results with graphene biosensors. Or preservation. Instead of blasting food with high heat, which can kill nutrients, new methods like cold plasma can sterilize food while keeping all the good stuff intact. And get this, for hazard mitigation, simply using a specific enzyme can cut the formation of a potential carcinogen in things like bread by over 80% without changing the taste at all. When you put it all together, it points to one clear goal. This isn't just about making cool, futuristic food. It's about building a whole food system that is fundamentally more efficient, way safer, and much more sustainable for the long run.
Take smart packaging, for example. Instead of a guessing game with a best before date, these new packages use chemistry to give you a live update. As microbes start to grow, they actually change the pH level inside. That chemical change triggers a film right in the packaging to change color. It's such a simple, brilliant way to see with your own eyes if your food is still good.
And how about sustainability? Well, this number is just staggering. According to our source, if we fully embrace a circular economy in the food system, upcycling things like brewery waste into new ingredients, we could potentially slash the food system's global emissions by almost half. That's 49%. This is chemistry being used as a powerful tool to help the planet.
And that brings us to our final stop, our molecular future. We've seen how chemistry is changing a single dish, a single ingredient, and the entire global supply chain. So where is all of this ultimately headed? What does the future taste like? When it comes right down to it, the future is all about finding this perfect balance. The goal isn't just to make food scientifically fascinating. It's to create things that are an absolute delight to eat, while also being demonstrably safe, incredibly nutritious, and produced in a way that's actually good for our planet. And if you want to see the furthest edge of that future, look no further than note-by-note cuisine. It's a concept from the physical chemist Hervé Thys. The idea is to stop thinking about ingredients like carrots or steak. Instead, you build a dish from the ground up, using the pure chemical compounds that give those things their flavor, their color, their texture. It is the absolute pinnacle of precision. And that leaves us with one last huge question to think about. As we get better and better at building our food molecule by molecule, are we actually ready for it? I mean, it's one thing to use science to bake a better loaf of bread, but it's something else entirely to eat a dish that was never a plant or an animal, but was constructed entirely in a lab. It's definitely something to chew on as the science of deliciousness keeps marching forward.